Again, the partial differential equation for this model can be explicitly solved. Here, the Sharpe ratio is defined as a constant times square root of r divided by the sigma term. So here, we're allowing the Sharpe ratio to be proportional to square root of r, and one might argue that this is a natural expectation that as interest rates get high, investors are potentially taking more risk, and they should require extra return per unit of risk. But in any event, this differential equation can be solved for this assumption on the Sharpe ratio. And notice that it produces the same format as the Vasicek model, identically the same notation and format, different definitions of the A and B functions. And in the A and the B functions, they're much more complex. You will see the parameters of the stochastic process, A, B, and sigma. You'll also see the Sharpe ratio. Phi bar is the constant coefficient of square root of r that's part of the definition of the Sharpe ratio. And there's also a new parameter, gamma, which is not actually part of the stochastic process. This is just a notational device where you can see gamma is defined as a square root of an expression involving parameters from the process as well as the Sharpe ratio. You'll note R bar, again, defines the interest rate when the term of the zero coupon bond gets very long, goes to infinity, if you will. It's the limiting rate. And we can see that unlike the Vasicek model, R bar isn't a function of sigma, so you don't have the undesirable property that the long-term spot rate goes to zero and negative when the term increases and volatility is high. So all these parameters are defined, and so both Vasicek and Cox-Ingersoll-Ross have the same structural model for zero coupon bonds. They have a couple of constant functions, A and B, and they only reflect today's interest rate, that all of the expectation associated with future interest rates from today that come from that risk-neutral expected value of spot prices, of zero coupon bond prices, all of that is consolidated into the A and B functions. And we therefore only need to know today's short rate.